Hello everyone, today we will look into simplifying radicals, and in order to simplify we will find perfect squares and then simplify each perfect square. Here is your vocab. Radical is the formal name for the square root symbol. The expression square root of 9 read as root 9, radical 9, or the square root of 9. Steps for solving simplifying radicals. We will first factor the radical into product of perfect squares and other factors. We will identify the perfect squares, then we will solve the radical with the perfect squares inside. We will rewrite our final answer as a whole number and a radical. At this point, I would like you to list the perfect squares you know. Pause your video and I will make a list for us too. Here is a list of all perfect squares up to 20. Most of you are pretty comfortable at least up to 10, so please try to remember the perfect squares up to 20 as well. Let's look at a couple of examples. When you look at a number, you're trying to identify perfect square factors. If 20 itself would be a perfect square, then we would not have to look for perfect square factors. And two numbers that I can think of, the biggest perfect square number I can think of for 20 would be 4 times 5. So we will write 20 in terms of 4 times 5. 4 is a perfect square. 5 is not a perfect square. Each time we identify a perfect square inside of the square root, we're going to take the square root of a perfect square. Square root of 4 is 2, and 5 is not a perfect square, so it will stay inside of the square root. Our final answer would be 2 square root of 5. Let's look at our next example. Try to find the largest perfect square possible. Most of you probably are thinking about writing 4 times 12, but we have even bigger factors that are perfect squares. I can see 16 goes into 48 3 times, so I can use 16 and 3 as my factors. 16 is a perfect square. I'll circle that one, and I'll take the square root of the perfect square, which is 16. Square root of 16 is 4. That goes outside of the square root. And 3 was not a perfect square, so it will stay inside of the square root. Our final answer is 4 square root of 3. Our next example is 75. And because there's a 5 in it, it kind of gives us a hint that we should have a 25 in there and a 3. This one is slightly different because there is also a whole number outside. When we have a number right against the square root or right against the parenthesis, we should always know that that number is being multiplied with the square root. In this problem, 25 is a perfect square, so I can take 25, square root of 25, which will be 5 going outside. 3 times 5, square root of the 3, other 3 is staying inside. Since 3 and 5 are outside in multiplication, I will multiply them. 15 square root of 3 will be our final answer. Here's your U-try. Now let's find the square root of products. When we multiply two square root expression, we can write the multiplication inside of one big square root. So 3 times 18, inside of the square root will multiply with inside, and if there would be a number that's outside of the square root, that would multiply with the outside of the other square root. Square root of 54 in this case is not a perfect square, so we're going to have to think about perfect squares that could go into 54 evenly, the biggest perfect square. So the biggest one I can think of is 9 and 4. So we're going to write square root of 54, excuse me, not 4, 9 and 6. Square root of 54 is 9 times 6, square root. We know 9 is a perfect square and it will go outside of the square root as 3, and 3 root 6 is our answer. Sometimes you will see square roots and variables together, and we will treat variables just like we would do to perfect squares. And x squared would be a perfect square expression. X cubed is not necessarily a perfect square, so we're going to try to find perfect squares in it. Now, let's multiply our numbers with numbers and variables with variables. 20 times 8 makes 160. X cubed times x squared. During multiplication, when bases are same, we add the exponents. At this point, we're going to try to find perfect squares. 160 is 16 times 10. X to the 5th power can be separated into, can be split into x to the 4th power and one more x. These are still in square roots. I will identify the perfect squares. 16 is a perfect square and x to the 4th power is a perfect square. Because in order to get x to the 4th power, we would need an x squared and then another x squared, which would make x squared to the 2nd power. Remember your power to power property. So x to the 4th power is a perfect square. 16 is a perfect square. 16 can go outside as 4. Square root of 16 is 4. X to the 4th power will go outside as x squared. Inside we still have 10 and one of the x's left. And this will be our final answer. Here is your U-try. If we have a question involving division and square roots, we can assign the square roots and division together, and I can rewrite this expression under one big square root. First part and the second part, since they were both in square root, I put both of them into one big square root. 27 divided by 12. Before trying to take out perfect squares, let's try to simplify this fraction first. 27 can be divided by 3 and 12 can be divided by 3. We can rewrite this problem as 9 over 4. Now we can identify perfect squares and then we can write our final answer. Square root of 9 is 3, square root of 4 is 2. It turns out that our answer did not have any remaining square root expressions, so our final answer is 3 over 2. Let's look at another example where we have variables involved. If I put both of these into one big square root, we will have 5a cubed divided by 48. Now 5a cubed and 48 do not have any common factors to simplify. So at this step we are going to try to identify perfect squares. 48 can be split into 16 and 3. A cubed can be split into a squared and one more a. So let's write our problem again. 5a squared, one more a, divided by 16 and 3. At this step, we can identify perfect squares, and we will now take the square root of perfect squares. A goes outside, inside you still have 5a. And on the denominator we have 16 as a perfect square, which will go outside as 4, and inside of the square root will be 3. As you can see, when we have a division problem, I can split the division problem into two square roots, or if I have a problem that has two split square roots, I can put them into one big square root. And as a next step, we are going to look more into a square root of 5a over 4 square root of 3. It looks like this is our final answer. However, there is some issue. We have an issue with this result because we don't want to have a radical on the denominator. In order to get rid of the radical on the denominator, in order to rationalize the denominator, to make a rational number, we would multiply the denominator by its complement. Complement of the denominator would be the square root term that's in the denominator. So we would multiply the denominator with the complement. Complement would be square root of 3 because that's the square root part on the denominator. If I multiply denominator with a number, I must do the same multiplication on the numerator. At this step, we would just do our multiplication. A square root of 15a. When multiplying square roots, the outside number will multiply with the outside numbers. There is nothing in front of square root of 3. And inside of the square root will multiply with inside of the square root. 5a times 3 is 15a. Divided by, you have 4 square root of 3 and square root of 3 together makes 3. Our final answer is a square root of 15a over 12. In our final expression, we do not have any square roots on the denominator. It's okay to have square roots on the numerator, but we do not want square roots on the denominator. That's why we will multiply the square root with its complement. I also want to repeat this section where we multiplied square root of 3 and square root of 3 and got 3. If you multiply an expression with the same expression in square roots, then the result will be expression without the square roots. So it could be x square root of x times square root of x is equal to x. Square root of smiley face times square root of smiley face is equal to smiley face. Please write this somewhere on your paper so you will remember. Here is your U-try. Try to simplify first and then find the complement of the denominator to make the denominator a rational number. That's pretty much it. Please make sure to bring any question you have to the class.